Okay, let's continue with chapter 6, circular motion. For this video, we're going to look at 6.2, centripetal force. So the learning outcomes is for you to be able to define centripetal acceleration and then solve problems related to centripetal force for uniform circular motion in three cases. The first one is horizontal, vertical, and then conical pendulum circular motion. Okay, centripetal acceleration, the symbol is AC, is the acceleration of an object moving in circular paths with the magnitude equal to the square of the speed divided by the radius. So V squared over R. Its direction is always towards the center of circular paths. Okay, so kalau kita ada bulatan, AC sentiasa menunjuk ke tengah. So last time we already looked at linear tangential velocity, where it is the tangent for the circle. So this is the V moving in straight line. And then AC is moving towards the center of the circle, and they have 90 degrees between each other. So the directions of centripetal acceleration is also perpendicular to linear tangential velocity. Okay, so according to Newton's second law, F equals to ma. Right, so because AC, centripetal acceleration is moving towards the center, which means that the direction of centripetal force is also going towards the center. So they have the same direction. So the formula for centripetal force, Fc equals to mac, in which AC is equals to V squared over R. Okay, so when the centripetal force is removed, the body moves in straight line with constant speed. Okay, for example, if we are using a string to make a vertical circular motion, and suddenly the string snap, tali itu putus, jadi this object will continue moving in straight line di bahagian mana dia putus lah. Okay, so it moves in straight line following the directions of the linear tangential velocity. Okay, let's say kalau dia putus kat sini, ini adalah direction objek tersebut lah, in straight line. Right, so now we look at the problems for centripetal force. Okay, we know that centripetal force, the direction is always towards the center of the circle. But this centripetal force will be contributed by different types of force according to different cases. Okay, for example, in this case over here, we have a string making a horizontal circular motion. So if we draw FPD for the object, for the pendulum, so the tension is in the directions towards the center of the circle, which means that the summation of Fx is equal to Fc, and the force acting along x-axis is tension. So Fc equals to T. Okay, another case, satellite orbiting the Earth. Okay, so there is a gravitational force acting on the satellite at any position. At any position, the gravitational force is pointing towards the center of the circle, okay, the orbit. Okay, so which means that Fc is equals to Fg. Okay, how about a car making a turn? So when this car is trying to make a left turn, there is actually a static frictional force opposing the car to prevent it from moving to the right. Okay, so this static friction, we moved it to the circle, we can see that it is actually in the direction of the center of the circle. So Fc now is equals to the frictional force. So in this case over here, we have the same situation where we have a string, which means that Fc is equals to T. Okay, horizontal circular motion. Here we have different cases. The first one is for simple pendulum, motion of a car around a flat curve, conical pendulum, and then motion of motorcycle. Okay, so the first one, kita tengok dekat simple pendulum. So we assume that this pendulum is making a circular motion in air, dalam keadaan udara lah. Dalam udara, dia buat bentuk horizontal circular motion. So if we draw the FPD for the pendulum, this object has a mass, jadi dia punya weight will go downwards. Okay, and then we know that if there is a string, dia akan ada tension force moving away from the object. Okay, now the tension force dia adalah along the string dan dia menuju ke arah center, which means that this tension dia sama arah dengan AC, sama arah dengan Fc. Okay, therefore the summation of Fx is equal to Fc. Fx kita ada tension sahaja equals to MAC. So from there we can expand jadi mv square over r. So if you need to find the tension of the string dalam soalan, you can use this formula. Okay. Okay, so kalau contoh dalam Newton's first law, kita buat summation of F sama dengan kosong. Kalau dalam Newton's second law, summation of F sama dengan MA. But then for centripetal force, kita buat summation of F sama dengan MAC. Okay, so this one could be X or Y depending on the orientation of the circular motion. Kalau circular motion tu horizontal, jadi Fx dah. Kalau circular motion tu dia vertical, dia jadi Fy. We have another case in which the horizontal circular motion berada di atas meja. So let's say this is a string, this is the object. Okay, dia buat bulatan di atas meja. So in this case, our FPD will be a bit different. Di mana tension akan sentiasa away from the object. Weight akan turun bawah, but then we have normal force because this object is touching the table. Okay, jadi beza bila dia berada di udara dan di atas surface. Right, we move on to number 2, motion of a car around a flat curve. Okay, around a flat curve. So, draw the FPD for the car. Okay, weight turun bawah, normal force naik atas, and then friction ke dalam lah, ke bulatan. In which we can see that the direction is the same as AC, the same as FC. Okay, sebab arah FC sentiasa sama dengan AC. So this time, summation of Fx equals to Fc, in which the force acting along X menuju ke arah center adalah friction. Okay, from there we can expand the formula for friction, mu n. Usually for this case, soalan akan tanya the value of the maximum velocity. Limiting speed lah, maksud kata if the car go beyond this limit, dia tidak akan membentuk circular motion, dia akan terbabas. Dia tidak membentuk circular motion. Okay. So from there you can cancel m if not given in the question. Don't worry because you can cancel them out on both sides. Then you can find the limiting speed. Okay, so this is summation of Fx. Okay, because the motion is horizontal motion. Okay, pada pasi X. And then summation of Fy is equal to 0. We have n minus w, so we can find the value of n. That will help us to find the value for n. Okay, the third situation is for conical pendulum. Okay, when we say conical, imagine a cone. Okay, so this pendulum is being attached pada satu tempat. Okay, but then dia punya circular motion masih lagi horizontal. Right. So if we draw the FBD, we have a tension along the string going away from the object, weight turun bawah. And then we can see that there is an angle that the string make with the vertical. Okay, jadi bila kita resolve, T sin theta, T cos theta. Okay, and then we know that the directions of AC at this position, they akan pointing towards the center. Okay, in which summation of Fx equals to Fc sebab dia punya bulatan berlaku pada paksi X. Okay, and then we can see the vector that following the directions of AC adalah T sin theta. So T sin theta is equals to MAC. Then we get one equation. But then you have to take note, R tu adalah radius. Okay, the most common mistake is that student substitute R with the length of the string. Salah lah sebab length of the string adalah panjang ni. Okay, this is the radius of the circle and this is the theta. If you want to find the value of R, kita kena pakai trigo lah, in which sin theta is equal to R over L, opposite over hypotenuse. Then you will get R. And then summation of Fy, we can see that along Y, kita ada T cos theta and W. So T cos theta minus mg equals to 0, T cos theta equals to mg. And let's say if we have two unknowns, kita ada dua unknown yang kita kena selesaikan. And then we have two equations. Jadi, we can use sin over cos to get tangent. Okay, so kita boleh dapatkan nilai V. This is the velocity for the pendulum dalam circular motion. Okay, for the car just now, V dia formula adalah mu gr. You don't have to memorize, kita akan simplify daripada kita punya persamaan. Okay, then we get this one, in which mu adalah coefficient of friction. The value is usually less than 1. Okay, for conical pendulum, kita ada formula lain, Rg tan theta. Okay, not advisable for you to memorize. You need to understand from the FPD. Kita buat FPD, kemudian kita simplifikan kita punya equation, kita akan dapat ni lah. Okay, and another one is motion of a motorcycle around a flat curve. Okay, soalan untuk motorcycle ni jarang-jarang keluar, but you need to understand the concept as well. Okay, different from driving a car, if we make a left turn, kalau kita belok kiri, badan kita akan sengit ke kanan. Tapi kereta tu tak bergerak pun. But untuk motorcyclist, kalau dia belok ke kiri, badan dia akan belok ke kiri juga, akan sengit ke kiri. Okay, so if we draw the FPD, we have the normal force di mana tayar tu contact dengan ground naik atas, but then the weight dia akan daripada center of mass, in which center of mass for human, untuk human being adalah di pusat. Okay, dan kita akan nampak dia ada angle yang dia sengit. Okay, so the reason why the cyclist bend towards the center of the circle is to balance the moment about the center of gravity of the cyclist. So the moment equals to 0. So later in chapter 8, you will learn about moment. So this in this situation, there are two moment di mana dia berbeza direction. Satu adalah anti-clockwise, satu lagi moment adalah clockwise. Jadi dia dah melawan arah, membolehkan motorcyclist ni berada dalam balance condition. Dia tak jatuh lah. But we will discuss that further in chapter 8. Okay, in terms of the equation, the summation of Fy equals to 0 because there is no motion along y-axis. But then we have n minus w equals to mg. So n equals to mg. Then summation of fx equals to fc, in which along x kita ada friction force. Okay, so friction equals to mv squared over r. Okay, if we focus the triangle over here, so actually we can use trigonometry. Sometimes you need to find the angle, sometimes you need to find the velocity. So let's say if you need to find the velocity of the motorcyclist around the circular motion, okay, you can use tangent, which tan theta is equals to opposite over adjacent, f over n equals to mg, f is the fc. So from here, if we expand the formula, we can cancel m, then we get v. But sometimes you need to find theta. Okay, so that's it for horizontal circular motion. In the next tutorial, we will continue with vertical circular motion. Okay, so for homework, exercise 6.2, horizontal circular motion, number 2, okay, this one, number 5, number 6, number 8, and number 10. Okay, so all the exercises will cover in terms of the simple pendulum, conical pendulum, car moving in circular motion, and motorcycle in circular motion. Okay, so again, your homework is 2, 5, 6, 8, 10. Deadline is on the 15th of September, which on Wednesday.